Today we're going to talk about waves. Please make sure you have your notes out and you're ready. By the end of this video, you will understand what a wave is. You'll also know the difference between transverse and longitudinal waves. So what is a wave? Well, a wave is a disturbance of matter that carries energy, and waves transfer energy from one place to another. But as energy moves, it's spread out and lost to the environment as the wave travels. So let's talk about this in an example in our daily life. When you yell at someone across the room, someone who is standing very close to you can hear you very clearly, but someone who is standing across the football field cannot hear you as well, because as you scream, those sound waves spread out and some of that energy is lost to the environment and you can't hear them as well. So there are many examples of waves. There are waves in the ocean, there's the wave at football games, there's sound waves, and we're going to learn about two types of waves called transverse and longitudinal waves. So transverse waves move up and down. So in this example right here, this transverse wave would move like this. In longitudinal waves, it's compressional waves. So the wave moves this way, and we'll talk more about that as we move on through this lesson. So there are transverse waves, and this is what transverse waves look like. Transverse waves have up and down or side-to-side motion. Examples of these types of waves are light waves, microwaves, X-rays, UV rays, radio waves, and rope waves. So this is like, for example, if you're at the gym and you're whipping away a rope up and down, that's an example of a transverse wave. In transverse waves, particles in the medium move perpendicular to the direction of the wave motion. So the wave is moving this way, but the particles actually move up and down. So they are moving perpendicularly to each other. And there is some very specific terminology that we need to use when we are describing parts of transverse waves. The first is wavelength. Wavelength is the distance between two crests or two troughs. So while this is a wavelength because it's between two crests, this is also a wavelength because it's between two troughs. Then we have crests and troughs. Amplitude is this distance from the midpoint to the trough or from the midpoint to the crest. So both of those are amplitudes. And finally, displacement is the distance between the crest and the trough. So now let's talk about longitudinal waves. I feel like it's really easy to think about longitudinal waves as compressional waves because that's really what happens. They compress. So this wave is moving and there's a spread out here. When they're spread out, that's called rarefaction. When they're close together, that's called compression. And wavelength is the distance between two compressions or the distance between two rarefactions. So in longitudinal or compressional waves, there's a stretching and squeezing motion that spreads out and contracts. And an example of this is sound waves or some types of earthquake waves. So if I was going to do this, this would be like if I used a slinky and instead of moving up and down, I just briefly moved my hand forward. That would cause this slinky to pass energy down it, and it would cause compression and rarefaction. Unlike in our other type of waves, of transverse waves, in longitudinal waves, the direction that the medium vibrates and the direction that the wave moves is parallel. So these movements and motions are parallel. So as we previously discussed, wavelength is that distance between two compressions or two rarefactions. And rarefactions is when things are spread out, and compression is when those things are close together. So let's talk a little bit about wave frequency. Wave frequency is the number of waves that pass through a fixed point in a certain amount of time. You can kind of think about this as wave speed. And our unit for wave frequency is hertz. And 1 hertz is equal to 1 wave passing through one fixed point in 1 second. So a higher frequency wave has more energy. than a low frequency wave if they have the same amplitude. So let's look at this. This is a high frequency wave. So I know it's high frequency because if I say that this is my 2 points right here, I can count the number of waves that go through that. And here it's 1 wave, 2 waves, this is 3 waves. If I do it through this same part, it's like 1.5 waves. So this longer wavelength has lower frequency and therefore it has less energy. High frequency means higher energy. So why do tuning forks make different sounds? On big tuning forks, the long tines, and the tines are this part of the tuning fork. On big tuning forks, the long tines vibrate more slowly, and this causes their waves to have a lower pitch and a lower frequency. So because they have a lower frequency, they produce a lower pitch than small tuning forks. On small tuning forks, the tines, which remember are these things right here, vibrate significantly more quickly. And because they are vibrating more quickly, they have higher frequency because those waves are moving faster. And because those waves are moving faster, that means they produce a higher pitch. So now we need to discuss the Doppler effect. The Doppler effect is something that you have definitely experienced in your daily life. So if you're sitting on your front porch, you can tell if an ambulance is moving towards you or away from you. And the sound, the actual sound emitted by the ambulance has not changed. The only thing that has changed is your relationship to where that sound is. So when the sound is coming towards you from an ambulance, you will notice that it sounds significantly different than when the ambulance is moving away. And that's because of this Doppler effect. The Doppler effect is the apparent change, not the actual change, but the apparent change in frequency of a wave. And like I said, this is caused by a changing position between the source and the sound of the observer. So now you should understand what wave frequency is. You should know what a wave is. You should know the difference between transverse and longitudinal or compression waves. And you should also understand what the Doppler effect is.